Welcome to a quick run through of some calculations for our friction lab. Just in case if it's giving you some troubles, I have some sample data here from the first trial in the video, and we can talk about how we're doing the calculations that we need to do. So our goal is to get to normal force data. We should have already gotten the friction data because we knew that the pull force was equal to the friction, and we got that directly from reading the Newton scale. But the normal force, we didn't have a direct measurement of. Instead, all we had was mass data. So, building backwards here, we should have in our lab planning and from our free body diagram that our normal force, the force up minus the force down for this sled, was equal to MAY. And since the sled was not moving up or down at all, the y acceleration was 0. Notice how we were actually using the y acceleration of 0 and the x acceleration of 0 for this lab, the key part to help us with these measurements. So since we know that the normal force has to equal the force of gravity, and the force of gravity is calculated by taking mass times our gravitational field strength, or gravitational acceleration, 9.8, and we are using 9.8 here because we're trying to be as accurate as possible. Well, what mass? We need it to be the total mass. It was the sled plus the masses in it. So if I take these two and add them together, 0.165 and the 0.100, the total mass of the sled and the mass in it in the first trial was 0.265 kilograms. Now, as we added new values, different amounts of mass, we'll get a different total mass every time. But for this one then, I can take my 0.265 kilograms times my 9.8 meters per second squared, or 9.8 newtons per kilogram, same thing, and do a calculation. If we were just in class, we would be saying, 0.265 times about 10. We would just move the decimal. And so we should get an answer that's somewhere close to 2.6. So 0.265 times my 9.8, and I get 2.597 on my calculator. 2.597 for my force. So 2.597 newtons. Now, let's note here, we have 4 significant figures, which we know is a stretch, but that is okay. I'm going to point out the 4 significant figures we had for the pull force, that wasn't a stretch because we were able to measure down to the line. There were lines marking the 5, and there was even halfway in between, and then we can always estimate past one more point past the line. So we could say 1.550 in this measurement. Okay, we have a complete line there, and when I graph then, I will be putting my friction data on the y-axis, my normal force on the x-axis, and you should end up with 7 data points that you can put on your graph and put your graph together, get your line of best fit, calculate your slope, and so what is the significance of that slope? That's one of the things that we're out to figure out in this lab. So, good luck, and I can't wait to see what you can do.